This video is going to talk about our new Keynesian model of short-run macroeconomic equilibrium and some of the advantages of our approach. Now really, there's two goals to this video. The first goal is to give you an introduction to the short-run macro model as it is presented in the book. Every book on macroeconomics is going to have a model of short-run equilibrium, and this one does as well. However, the second goal of this video is to give you some preparation on how to use the computer-based version of this model that accompanies this book. Now the model is pretty standard, but our presentation, we feel, has important pedagogical advantages. Now there are three equations to the model. The first equation is the familiar IS curve that tells us about goods market equilibrium, and that's this red line here that's downward sloping in output gap and real interest rate space. The second equation, which captures monetary policy, we call the real Taylor or RT curve, and that's this guy in blue that slopes upward in output gap real interest rate space. We use this instead of the LM curve, and we're going to be talking about the derivation of this curve in detail in a few minutes. Finally, the third curve is the familiar Phillips curve. This curve tells us that the inflation rate is determined by expectations of inflation, the output gap, and shocks to the short-run aggregate supply curve. Now, in this book, students are going to learn how core behavioral relationships determine macroeconomic variables. Here you can see the core behavioral relationships and the core variables: output gap, real interest rate, inflation, nominal interest rate. They're going to learn how different shocks affect these variables in a qualitative way. Now let's go equation by equation. Here's the IS curve. You can see the equation at the bottom. The equation tells us that there's an inverse relationship between the output gap and the real interest rate along the IS curve. The equation also includes an autonomous shock term, and we can see that the parameters of the equation include the responses of expenditures to changes in the real interest rate and also the marginal propensities to save and to import out of the output gap. Now let's turn to inflation and monetary policy. As a part of their background, students are going to learn about a continuum of monetary policies between two polar extremes, one of no monetary accommodation and another of full monetary accommodation. Recall that under the no monetary accommodation regime, all shifts in money demand are going to be transmitted to the interest rate. The money supply is assumed to be held fixed. This case corresponds to the well-known LM curve that is used in many textbooks. Over here, the central bank is assumed to be pegging the interest rate under a regime of full accommodation. We'll need to know about this when we talk about the open economy and a pegged exchange rate regime. But we're going to be focusing on an intermediate regime, and that's going to be Professor John Taylor's interest rate rule, and this is a special case of partial accommodation, and the key thing about this special case is that it is explicitly linked to policy objectives. Now, we often think of the central bank's objectives as twofold. First is stabilize the price level. We can see this in the Taylor rule by looking at the response of the interest rate to inflation when it exceeds some target or desired level. The inflation target can be explicit or, as in the case of the United States, implicit. We can also see the goal of output stability, such as Humphrey Hawkins' position of the United States. That's going to be reflected in the response of the interest rate to changes in the output gap. Now the Phillips curve, which once again tells us that inflation is a function of expectations, it's a function of the output gap, and it's a function of shocks to the short-run aggregate supply curve, is a constraint for the central bank. If the central bank wishes to reduce inflation and the output gap is positive, the central bank needs to raise interest rates so as to reduce aggregate demand and hence the output gap. Accordingly, since the Phillips curve is a constraint, we substitute it into the Taylor rule and we express this new equation in real terms. We call this new equation the real Taylor or RT curve. Unless the zero lower bound constrains, this curve slopes upward in interest rate and output gap space. for simplicity, we have not shown the case of the zero lower bound in this slide. Here we can see a more complete graphical presentation of the real Taylor or RT curve. On the horizontal axis, we have the output gap. On the vertical axis, we have the real interest rate. The leftmost portion of this curve is zero lower bound territory. The economy is experiencing an extreme downturn, and the nominal interest rate is stuck at zero. It simply can't get any lower. This means that if the output gap falls, inflation falls, and the real interest rate rises. Therefore, over this segment, the RT curve is negatively sloped. More generally, when the zero lower bound is not constrained, the RT curve slopes upwards. Now, you may know that there's been an ongoing debate amongst economics educators, should we continue to use the LM curve? Well, we're going to use the RT instead of the LM. What are the advantages of the RT approach? Well, first of all, unlike the LM, the RT explicitly links the interest rate chosen by the central bank to some of its policy objectives. Secondly, the RT curve includes a term for discretionary loosening or tightening, and in this way, students are able to distinguish between rule-based policy and discretionary policy. Also, the approach conveys the idea that the Phillips curve is a constraint for central banks, and this approach allows us to easily incorporate the zero lower bound into our analysis. Now, as I mentioned, not only in the book is this model implemented, but also on the computer. And we feel that this computer model is an integral part of the learning package. We're sure that you're going to find this model very, very useful to demonstrate a wide range of alternative scenarios. You will be able to assume different kinds of shocks occur, and the model will show results both verbally and graphically. You'll see in the next video how easy it is to enter shocks for alternative scenarios.